Today's lesson is on the graph for sine and cosine. By the end of this lesson, you should be able to graph f of theta equals sine of theta and f of theta equals cosine of theta. Reminder, this f of theta is just like your y. That theta is just like an x, but generally is used to represent an angle. So at the end, you should be able to graph y equals sine of theta, y equals cosine of theta. By the end of this lesson, you should be able to explain why is it that sine of theta has a repeating pattern and why cosine of theta also has a repeating pattern. Finally, by the end of this lesson, you should be able to determine the period and amplitude of sine and cosine. Okay, so this video will guide you through the notes for this. First thing I want you to do is while the majority of this video, the majority of the stuff that you can write, it's easy to write it on the computer. It's much easier to actually graph on a sheet of paper. So what I want you to do is set this graph right here up on a sheet of paper. So your y-axis should go from negative 720 degrees all the way to positive 720 degrees, counting by 90 each time. So 0 degrees, 90 degrees, 180 degrees, 270 degrees, etc. And I want you to put your y-axis from positive 2 to negative 2. Pause the video here, set that up. When you're ready to continue, hit play. Okay, next thing I want you to do is in this table, fill in the values for your y or your f of theta. So this is for the equation f of theta equals sine of theta. So example, what is sine of 0 degrees? Write that right here. Sine of 30 degrees, sine of 60 degrees, sine of 90 degrees. So write it in here. What I'm going to suggest is that you do this on a calculator, and in these spaces right here, write your answer as a decimal approximation. So write your answer as a decimal. Whenever you are, if you start doing this and you notice the pattern and you're 100% sure you understand the pattern, feel free to just use the pattern to finish filling in the rest of the spaces here. If you're not 100% sure you understand the pattern, well, just put each of these into your calculator and it'll come out with the sign for that angle. Pause the video here. When you are finished with this table, hit play. All right. Now, what I'm going to want you to do is plot these points on your graph. So a reminder, this theta is like your x, and this f of theta is like your y. So plot this point right here, your x and your y. Put a dot where that is. Then put another dot here where 30 degrees is your x and whatever you got here is your y. And I want you to plot these points onto your graph up there. Whenever you're ready, after you finish doing that, hit play. Okay, now that you've had all these points plotted, what I want you to do is basically connect the dots to make a smooth curve. Pause the video here, hit play when you're ready. So now you should have a pretty smooth curve on this right side here. What I want you to do is go on to the question number 1 and 2 in your notes. You can type this on this Google document, or you can type it in on a sheet of paper and turn that in. after you have finished, so here it says the shape of the graph for f of theta equals sine of theta repeats every blank degrees. So you should have some sort of repeating thing up here, and they just want you to write how long it takes before the pattern starts to repeat, how many degrees. Next, I want you to use your unit circle. This is a circle of radius 1. Use that unit circle to explain why the pattern repeats every blank degrees. Pause the video here. Hit play when you're ready to continue. Okay, once you are done with number 1 and 2, I want you to use your pattern to fill in the left side of this graph. So use your pattern to fill in from negative 720 degrees to 0 degrees. Pause the video here. Hit play when you're ready to continue. Okay, so now you should have a full graph. And at this point, I want you to finish answering number 3 through 5. Number 3 asks you for what is the period of your graph. Period is defined as basically the distance. It's horizontal distance, so your left and right distance from the peak or the top of one wave to the next peak. So your graph looks maybe something like this. So here, let's do in green. The distance, this is one top right here. Looks like I have another top right here. So the distance from here to here is your period. So on your graph, figure out what the period is for f of theta equals sine of theta. When you're ready to continue, hit play. Next, we're going to look at another thing called amplitude. Amplitude is the vertical distance from the peak to the center line. Let me show you what that looks like here. This line right in the center this line right here, that is your center line. Basically cuts the picture in half. So your amplitude is the distance from your peak to your center line. So that distance right there. Let's make it a little thicker. So that distance right there is your amplitude. If you don't really like that definition, another definition for amplitude is half of the distance, half of the vertical distance from the peak to the trough. This means bottom, so from the top to the bottom. So if I look at, here is your top, right? Here's your bottom. So half of that vertical distance, so take that vertical distance and then divide it by 2. That is another way we can define the word amplitude. Pause the video, calculate the amplitude for your graph. Hit play when you're ready to continue. Okay, so now that you have your amplitude, I want you to use your unit circle, once again that's a circle radius 1, to explain why your amplitude is what it is. Stop here. Hit play when you're ready to continue. Okay, so now that you've done this, I want you to basically go through the same sort of steps in order but for f of theta equals cosine of theta down here.